Even if you don't work with Meyer sound products regularly, you should definitely learn MAPP 3D. In my opinion, it is the best sound system prediction and design software out there. And the best part, it's totally free. It is now in 3D. It used to be only a 2D only software with MAPP XT, but MAPP 3D has changed all that. I've been learning it and putting it to work on the shows that I'm on. Even if I'm using a different manufacturer's speakers, it can still do some things that most other softwares cannot. It is high resolution data. You're able to have a virtual system processor and make changes and see how that reflects in the field. And you're able to have virtual microphones and move them around and practice taking measurements. So if you're a beginner and new to this, there's no better environment to start learning this when you can't always be out on shows in the field. Maybe you don't have the gear. So please start here. Today is a tutorial from me walking through the core features of the software. I don't work for Meyer, there's no affiliate, there's not anything, so I'm sure I'm going to get something wrong, and please fact check me if I am getting something wrong. But this is just showing my approach to the software and the workflow, and is hopefully an addition to the fantastic resources that Meyer already has out there on sound system design and engineering. If you're into making your sound system sound amazing, I think you're also going to love my Audio Mass Survival spreadsheet. It's available at the link below or at producedbymkc.com/audio toolkit. It's got over 30 different calculators that help you get real results in the field. It starts by getting you used to how frequency, period, and wavelength are related. You can count phase delay. This helps you align mains and subs. It can get used to the decibel scale, and there's a whole lot more in here. So make sure and grab that at the link below or at producedbymkc.com/audio toolkit. I think you're going to love it. All right, so let's jump right into MAPP 3D. Let me give you a roadmap for today, then we'll jump right into our main content. First, we'll be talking about why MAPP 3D. Even if you don't work with Meyer sound products regularly, I'll still think it's well worth your time to learn this if you want to level up in sound system design, alignment, and tuning. We'll talk about how to download and install it. We'll get to the project settings, learn a few mouse and key commands. It'll be real short. We'll do an overview of the GUI, how to get a lay of the land and where to find things. Then we'll jump into creating your own venue and audience. We'll work with layers, talk about importing SketchUp files and how you can view the project differently. We'll start adding sound sources like speakers. We'll jump into this built-in signal processor, look at prediction data, then add some microphones, and so we can look at the measurements we take, and then we're going to build the whole project we'll be walking through again from scratch. So we start with it finished, walk through all the settings, I'll zero it out, and just so you can get used to building a file, and you will build that along with me. So let's jump right into why you should learn MAPP 3D. Got 5 reasons. The first is that it is high resolution. You get 48 points per octave of data. And what that means is that if you're on a graphic equalizer, that is a 31 band EQ. So between the 1 kilohertz fader and the 2 kilohertz fader, you have 48 data points. So that's really high resolution and great data. You can, of course, apply smoothing if you want to look at it to make it a little bit easier, but it's very, very accurate data. Meyer has written several white papers showing how their previous software, MAPP XT, and now MAPP 3D, does a really good job and is very painstaking of making sure what you see in the software is what you're going to get in the field, minus any super weird room acoustic stuff. Number 2, it is complex measurements, meaning that you have both amplitude and phase data. Other softwares, you can only get the complex data up to a certain frequency, or it takes forever to calculate, or you don't get it at all. So I love that you can see phase and start to learn that within this software. Number 3 is you have virtual measurement mics. That means you can take a microphone, put it anywhere within your design, and get an accurate capture of data. You can look at phase, amplitude, the impulse response, anything given all the sound sources in your space. You can actually practice tuning and place measurement microphones in the project and look and see where you're going to find your own mic locations and plan that ahead of time. I think it's a really useful feature, and you're not just looking at an SPL graph chart or whatever. You are looking at real measurement mic data. You can also export that and bring it into a software like Smart or Open Sound Meter and compare those measurements with what you actually get in the field, which is pretty cool. Number 5, it really is the complete package to simulate everything you need in the field, except the room itself. That's really, really hard. It's super complex math to get that super accurate. And so they have everything that is under their own control there. The speakers, great data from that. You have the actual placement and measurements from the microphones. And it's really easy to extrapolate that data and apply it to other manufacturers. So, an X40 speaker that we'll be looking at today is 110 degrees by 50, I think. And so you can find a similar speaker from another manufacturer and get, let's say that manufacturer doesn't have a great piece of software. They don't have it at all. You can jump into MAPP, make those calculations and estimates and be able to extrapolate that to the field. It's also a great place to practice in. You have measurement microphones, you have a full-blown integrated system processor, and a lot of speakers that sound great to work with. So I think it's a great tool to learn, even if you don't work with Meyer sound products regularly. I've only been on one show where I've used Meyer speakers, but I still love the software. Here I've got our MAPP 3D session open. Here's a simple file that I've built. Here are a few mouse and key commands before we start diving in. The scroll wheel zooms in and out, and this works both. I have a mouse here and a trackpad, so you can zoom in and out like that. The hold down shift will turn into this little hand you can click and drag around laterally or up and down. And then a spacebar, click and hold, or press and hold, you can orbit around the design on the axis. So you can go back here. I'm going to go back to the original view here, but those are really good to know. You can also use Command plus to zoom in, and then I would hold Shift and then move over to where I needed to be. All right, so how to download and install this software. Go to meyersound.com. You want to go to Products. This is both Mac and PC compatible. Go here to MAPP 3D, Design and Prediction Tool. Then you're going to want to go to Account and then Log In. But if you click Log In, you don't have a login yet. This is your first time. And you're going to want to click now here on Register. So it's not the most intuitive thing, but here you go. Click Register. You put in your information and then you'll basically make an account with it. And then you'll go back and log in. And here, once you get those credentials over email, click Log In. Go back to Account, and then we have download MAPP 3D for Windows or Mac OS, whichever you are on. All right, now we're back in the software. We are going to recreate this at the end, but I'm going to use it as a demo and step through what's going on. So Shift Command P opens up project settings. You can also go File, Project Settings. And I'm just going to set through these tabs. We have the units. I have in feet and pounds since I'm in the US, and Fahrenheit. I think this defaults to metric units. And then an environment, I set it to 72 degrees. It's going to be at 20 something, I think, if you switch it from Celsius. So make sure and bump that up. I also moved the power supply voltage to what's normal for what I run on 115. So if you want to do any power calculations, it's doing that. If we go to appearance, I leave these all at default. The only thing you might want to change is the color scheme to black or white. So if you're outside and it's a lot of daylight, sometimes the black doesn't show up very well, just like any other dark mode software. SPL will come back to, but this basically alters the graph of what's going on. You can, as far as you looking at the SPL of a given frequency over your prediction plane. So the measurement units, you can put it in raw SPL, and I usually keep these on default, and that's with that speaker at a given distance, you can know its exact predicted SPL. And so if you have a big giant Panther array versus a little X40, obviously the Panther is going to be louder, and you can know the real SPL if you were to drive it with the generator level you have. So up here on the top left is the generator, and you can adjust its level, and I often run it with pink noise. What I think is more helpful to us as system designers, once we know that we have enough PA to do the job, is attenuation. So that sets 0 dB as the top, and then it can go down 18 dB and does that in colors. So let's see what this design looks like. And then we always have to go up and hit the predict frequency, or predict button. I can see here my given frequency 4K at a 1 octave band. That is my design. It's not perfect. We need a little bit of love here on the sides, but the vast majority of the audience is within this graph. Everything that's yellow and above is within 6 dB. But if I went back here and changed this SPL to the SPL measurement back up to here, this graph would change, and now it's a cool blue because that's going to be averaging 83, 85 dB right here because that color corresponds with that graph. So it's going to be the same color scale, but now we can actually adjust to real SPL instead of something that is relative to 0 then going on down. Moving back to the processor tab, you can engage the atmospheric correction response. I really don't use this very much, but that's where it's at. And then on measurement, I leave this all at default. Let's look at the main GUI. It's divided intuitively into 4 different panes. Here's our left pane. We have our center pane. And then we have our right pane. And then this kind of top strip up here. So we'll step through those sequentially. So first up on our left pane, we have geometry. So these are things you're going to draw in the space to simulate an audience, a stage, a venue of sorts. So on the right-hand side here is where you can click different shapes and draw them in, which we'll get to, but this lists all your shapes. So right here, I have a stage and I can select that, and that's what I've built here. And then I have an audience. If I click here on prediction, that gives me a checkbox of saying, hey, I want to use this surface to cast audio on. So it's like taking a slice of the speaker's response in space across that prediction. And I have that prediction plane 4 feet high. And we'll come back to that a little bit in the object settings to show how I offset that and made that at sitting height. So geometry will list everything you've drawn for the venue itself. And then I have signal processors. I can add more of them, but the main one it's going to default to is the Galaxy 816. That is here. It is a 2RU unit that has gain, delay, all pass filters, EQ, everything built into it in the box. And then it has, I think, 8 inputs, and then 16 outputs. So this is the output you would feed to a particular speaker or zone of speakers if you're daisy chaining them. So we basically have a virtual Galaxy 816. Here we can add more if our system is bigger, but we have that in full simulation within our software. And we're going to change that later by clicking on processor settings. Then we have it right here. We can also link that up with the Compass software, which would be the software you'd be running in the field and have them exchange data. But that's beyond the scope of today. We're just hitting the fundamentals, but that is, it's a really cool feature that you can link those together. Going here to our loudspeaker system. This is where all your speakers are going to sit. I've labeled them here, mains right, sub, front fill, mains left. For some reason, you can't reorder this list. That's unfortunate, but if I select this speaker or deselect here, mains right, and it gives me those little X, Y, Z coordinate little guys and a little ball, and then I can select this one. So that's where if I wanted to find a particular speaker, I can just scroll in this list. I can also rename it here by double clicking. Or if I clicked on the speaker and went to object settings, that name is also reflected here at the top. Lastly, in our left pane, we have our microphones. So they're kind of hard to see, but I try to make them pop out. So this little teal color, I have them right here. 1, 2, 3, 4, 5, and they're at specific spots for a reason. We'll get to those later, but that's where they are listed. These are very similar to receivers in Ease Focus 3. They just collect data. It doesn't matter where they're pointed. They're going to pick up omnidirectionally, even though measurement microphones in real life don't do that. These will in this software. I don't have to worry about pointing them exactly at a speaker. I have them at 4 feet high at the same height as my prediction plane. How to view the data is we go over to measurement view, and I can select a particular microphone and look at what's going on and look at the amplitude response, the phase response, and the impulse response right here. So we'll dive a little bit deeper into this tab a little bit later, but just so you know, that's where you look at that data from a particular microphone. Moving on to our right pane, we have different tools. We have select, we have grab, we can orbit and measure. So the select tool is what I've been using to click around. The grab tool is I can grab the screen and move it. That's the same as our hold shift. So I like leaving it on select, hold shift. I can move. Orbit is spacebar, so hold spacebar and grab an orbit. And then this is our distance tool. You can click on it. I can go from the corner of the stage and click on the other corner, and it's going to tell me it's 24 feet. I can also keep going, click, and go to this one. Or I can even measure from a point on a loudspeaker to a microphone, and it tell me its distance that it's throwing. So that's really handy. I didn't know this for a while. I just kept restarting the software. Thought it was a bug, but you can't click on any other tool until you hit escape, and now you are back to normal. This scale tool can take something and scale it up proportionally. The rotate tool will take something and rotate it around. The align tool can help something move together as a unit. And the mirror tool flips something across its edge on a different axis. I can zoom in and zoom out. And then we can zoom to extents, which basically puts it to where everything that's in the project, it has all within its view. So that's really handy, just kind of snap out. If you were zoomed in and really trying to place a microphone specifically, look at something, I can click this and boom, it pops me right out. And then the array, I'm actually not sure what array does. So we'll just call that beyond the fundamentals. Then we have the primitives. Primitives are the shapes that we can draw. Most likely, you're going to be using the rectangle to draw an audience shape. You may be in a venue that's a little bit more complicated than that, but all I did was click on rectangle and drag out, and here it is. I can click on it, go to object settings, and this is where I would adjust its position. I can rotate it, and I can do its depth and width. I'm going to go back and delete this guy since I've already made it. Yeah, but these primitives are 2D shapes or 3D solids. I can also go here to modifiers, and this is how I would change a shape in a certain way. Again, most of these are beyond the scope of today, but extrude's going to take what was my rectangle and lift it up. That's how I did this stage. And I was able to lift it up into a solid by extruding out the edges of it. Union will join two shapes. Trim means if I have something that's overlapping, I could trim out the lines that are overlapping and just have the outer edge. Intersect will have them, it's kind of hard to explain. It's kind of like a union and subtraction. Anyway, we can come back to that. Offset, we're not going to cover that. And the subtract actually takes two shapes and then subtracts them from each other. So I could take a circle within a larger circle and make a donut out of it, for instance. Then continuing on the right, if I click on an object, it'll show me more properties about it. So not a sound source, but a 3D or 2D object. So the stage, and I can easily adjust its depth and width right here, which is cool. I don't have to go to object settings every time. Then this is also where our layers are. So this is similar to Photoshop or AutoCAD, where I can add a layer and have a certain amount of objects live there. So this is really handy if I want to hide and show certain things at a time. I can now click on stage since I've assigned it to that layer. And how I assign something to a layer is I click on it, go to object settings, and it will right here under layer, and I can put it on that layer. I can add one by clicking add, or whichever one's selected I can delete. If I want to make a layer the active layer, meaning if I just click add something and it would go to that layer, because you always have to have a layer selected, I triple click. So if I want to go to front fills, and if I right clicked and I inserted a microphone, it would go to that layer. So I would say always make sure you are on the right layer and driving that. So make sure any of the choices you're making are only affected on that layer. I can also go here to Tools, Layer Management, and this is where I can change the color. So I make all my speakers yellow, the audience is gray, the stage is fuchsia, so it kind of pops out, and the mics are cyan, so they pop out on that blue. And I also make my stage always, the downstage center part of the stage is always at 0, 0, 0 in the designs that I make, so I always have a common reference point. So basically, if I have a front from the middle, that's always right there, and then the audience and move out from there. Moving on our right pane, we have viewports. So this is viewport 1. I can go and click here and look at my design in several different ways. So I usually like the isometric 4 as viewport 1, and now I'll click 2, and this is a top view, also known as a plan view, and I can look at it that way. Viewport number 3 is straight on, and the viewport number 4 is from the side, so I can see my subs versus my mains and what's happening there. And then I can save several of these. So like maybe I don't want left view, I want it right view for viewport 4. I got that. Or if I click on multiple, I can see all 4 at the same time, and I can click and draw something and see it reflected everywhere. And if I would make a custom view, I'll click create new, and I can save that. And that right here is what is camera 1 is something that I'd saved earlier. It's not very useful to me at the moment, but that's how I would get to that. To be clear with layers, these only group them from a viewing standpoint. It does not group any other properties like processing, and so it's not going to change anything that's happening with the processor if I accidentally put the front fill in the subs layer. It just helps you make sense and organize the project. So when it comes to creating your venue in your audience, you're going to start with geometry. So you're going to use a primitive to do that. Most often that's going to be a rectangle. I know a lot of venues are more complicated than just a rectangle, but we're just going to start with the fundamentals today. Again, my downstage center is always 0, 0, 0. We have an X is red, Y is green, and Z is blue. And this is a 20-foot deep by 24 wide stage. And this is a 60-foot deep by 70-foot wide rectangle for the audience. So the audience, I could click on it, and its setup is I have it 10 feet downstage of downstage center, because let's say I have some imaginary bike rack right there, so I know the audience is not going to go more than that. But we talked earlier about this prediction plane, and so if I uncheck that, that goes away. So this kind of purpley blue hue is where the SPL measurements are going to show up. So how I made that there is I clicked on prediction, and if I did not offset this, it would be on the floor because my audience position, its Z is 0, so that means it is on the floor. So I made it this depth and width. I positioned it 40 feet, that always references from the center, 40 feet out to the audience. And then the object face, I made it prediction, and I made the offset 4 feet high for a seated audience. And then I made sure it was on my audience layer. That is the only object on the audience layer. To give you a quick look about how I made the stage, I'll just draw it next to it as I made a rectangle. Just clicked and dragged that out. I went here to modifiers. I went extrude and did a linear extrusion along the Z axis. So it's going to move it up. I want it to be 4 feet high. So I extruded 4 feet and then hit apply, and boom, this kind of popped out 4 feet into a 3D solid, which is pretty cool. And that's how I got my stage. I made sure it was on its layer, and I colored it fuchsia. You can also import SketchUp files into here, file, import, or DXF, which is awesome. We're not going to do that today, but just know if you have worked really hard and got an AutoCAD design from an engineering firm or from the venue or whatever, you can import that in here. But I will say keep it as small and lean as possible. I think Meyer says under 25 megabytes if you can, so you don't need to have bathrooms and weird rigging that you're not using. Get it as lean as possible. Just get the general audience shape where the stage is, any of the rigging points, and then import it in there. And it will also keep the layers intact, so you're able to hide and show things as needed, just like you would within SketchUp or in AutoCAD or a similar software. All right, let's add some sound sources. I'm just going to go to our layers, and I've made sure and already added the layers that I want. Let's say we wanted to add another main. I would triple click, have this selected, it's going to be highlighted in blue. Then I'll right click out in this space and say insert loudspeaker system, or I can click file or insert loudspeaker system and do the same thing. It's going to pop up this window. I think by default it pops out with this awesome new Panther system. They're trying to show that off. So you can add a line array and change display angles and the processor outputs for all that. That's pretty cool. So today we're not going to get that fancy. We're just going to go down here to individual loudspeaker. I can also choose a ground stack loudspeaker system, a gradient flown subwoofer array, point source array system, endpoint source array system, or individual loudspeaker. Most of the time, if I'm not designing a flown loudspeaker system like a line array, I just go down here to individual loudspeaker, and I want to keep the reference point in front of the speaker. So I know that whatever reference points I have, it's going to do that, the grill, basically, the speaker right there. And then I can go through this giant list and select any speaker I want. The ones I have in the air today are the UPQ D3s. Those are an 80 degree by 50 degree speaker. And then I have a front fill that is the Ultra X22, I think, and it's 80 by 50. And then I have a single 750 LFC sub in the center. So that's how I would add a loudspeaker. If I hit apply, okay, that speaker is now here at the 00 mark, and it's now down here in my inventory and loudspeaker system. I'm going to rename it extra speaker, go to object settings. Now I'm going to put it 10 feet in the air. Let's rotate it down 45 degrees. And that's how I would change the speaker's orientation. Clicking on object settings, I can also change the model of the speaker on the fly. So if I already got something in the right spot and they say, oh, we can't get that speaker, you can just keep original positionings and all the processor outputs that you had and just change the speaker model. I'm going to delete this new speaker and we're going to move on to processor settings. So here is where we have our virtual galaxy. We have the 816 here. And by default, it has output channel 1, 2, 3, 4, 5, 6, 7, 8, all the way through 16. And I've relabeled these just so they can see them. And so if I click here on the speaker I've labeled mains left, I've also have an output channel mains left. So if I go to object settings, I click this, I see this speaker right here. I see that the output channel is also on mains left. So I can click on the speaker and assign an output channel. And then in the processor itself is where I change what's going on. Here is where I would select a different galaxy. If I had multiple ones, I can rename the instance of that. I can delete it, and I can export all the data I need. The device overview is where you're going to live most of the time, and I can see at a global level what's happening. I can double click on processing, and this is what brings up the EQ, the U-shaping, which is kind of like a broader filters. I can insert all pass filters. I have a parametric EQ. I have 10 bands available. Here's where I do my high and low pass filters. I can bring those in and out. What's great is I can click and slide this and it'll show me the corresponding, the orange line is the magnitude response and then the white line is the phase response. It'll show me what's happening there, which is really cool. I can add delay, gain, change the label. So this is more like a zoomed in part if I double click on that part. I can turn off any of the other processing from here. I can invert the polarity of the speaker, all sorts of neat stuff. And I can do that at a higher level right here on the overview tab. Gonna disengage that. I can also do delay integration. So this is the Meyer's way of making different speakers fit with each other. So I have this flown UPQ or UPD Q3, I forget. Anyway, that speaker is flown in the air and I'm able to click on delay integration and say, hey, what speaker do I want it to marry with? And here I have the 750 LFC, so that makes sure the phase response is gonna be happy. And I clicked on PC63 because that's where I want the lows to hand off right there. Meyer has a great entire webinar on this that you can check out. It's on their education page, so go look at that if you want to learn more. I can go here to polarity and invert that. I can add delay to that output. Again, this is a specific either AVB output or XLR output going just to that speaker. I can alter the gain and the mute and change the label. Moving through these other tabs, this is low mid beam control. This is a fancy way of adding strategic all pass filters to a line array to steer the low mid energy. It's beyond the scope of today, but that's where you would find that. I can look at output processing in this. I can click on a specific channel and see what's going on here. And I can go to snapshots and I can create snapshots of the galaxy. For instance, if I was touring and I knew I was going to be doing maybe 16 down on each line array per side for a specific leg of the tour. Then we were in smaller venues and it was only 10. I could have a certain amount of presets that are ready to get me out the door and ready. I'm not tuning ahead of the time, but I'm just having the galaxy set up how I want it to be. So that's so I can have a snapshot right there. Moving on to prediction data and SPL. Shift Command P, bring me to SPL. Right now, I have it on attenuation and full resolution. Let's take a look at that again. I'm going to hit predict, and it's up here on this center or top strip. I can choose my type of noise I'm setting to the system. I almost always leave this on pink. I leave my generator level at 0. And you can go and look at very fine resolution. For the most part, if I'm looking at coverage, I leave this on 1 octave, and you select the range here at 4K, because that's right in the middle of the intelligibility that we often look at for coverage, and I hit predict. I just had a single speaker selected, and it will only give me the coverage of that speaker. If I click off of it and I have no speaker selected, now it's going to give me the SPL at that frequency across the whole rig. So it looks like I'm doing a pretty good job here. Again, not a perfect design. One of my favorite settings that I stole from Merlin Van Veen. I was watching one of his webinars on MAPP 3D. I can link to those, but Meyer has a fantastic database of educational resources that you should definitely watch. As I put this on attenuation, I put it on 12 dB. And let me go back. Let's put it on 6 dB per color. So I can now have these in steps. So what's awesome is if it's in red, it's within a 6 dB span of each other. So this is a simple pass-fail mechanism to see if my entire audience is within 6 dB, which is the maximum tolerances that I want. So looks here, I probably, if I was going to work on this design some more, need some outfills, and then need to fine tune and make sure folks standing way back in the corners get there. And I would say this blue down the middle is just due to some of the overlap in the speakers and creating cancellations at that frequency at 4K, so I'm not too worried there. So just got to make sure I catch those edges as I update this design. You could also look at it even more granularly, but not at full resolution, so maybe 1 decibel per color. And that kind of gives you an easier way to read and interpret the data. So it looks like an elevation map and not this smooth amorphous thing. Let's look at taking microphone measurements. So again, they're tiny. I wish they would make these a little bit bigger. I know microphones are small, but I have this one in the front row, in the middle, and the rear. And if I'm really got to run and gun and get measurements quickly, this is my default placing. This is on axis with the main speaker. So if I go, or the main left, so looking from the top down, they are now here at the very front, the middle, and the back row on axis shooting through this speaker. So if you're doing a quick system tuning, this is always where I start. If this is different with a different audience shape, if I have like upper deck, lower deck, whatever, but just like a flat, normal audience, this is a good place to start. But if I go here to measurement view, this is where I look at all that data. And what's awesome about it is it's reflective of my processor settings. So let me go back to the processor. I have my microphones in the on-ax in front of mains right. So let me mute left, mute the front fill, mute the sub, and I go back to measurement view. And I'm going to now click over here to mains right. I want to select whatever speaker that is on that I'm focusing on. If I click on front fill and it's muted, I'm not going to get any data from the room plus processor because nothing's happening in the room. I'll always want to select the speaker that I'm most focused on. So mains right. I'm honestly a little bit confused by that. So if anyone's watching this from Meyer who knows, please let me know below. But I know I can select multiple outputs even if there's other outputs on, so I'm not sure what's going on there. So I probably need to look at the manual a little bit more closely. But here I can now select the microphone. So I've labeled these front, on axis right, mid, and rear, and I placed 2 of their microphones. This is where I place them for the main to my front fill alignment and then my main and sub alignment. So here's the front microphone. And then I would go down here and click auto on the propagation delay, and it's going to tell me the propagation delay from the speaker where the impulse response is strongest, and it's only one spot since it's just the mains right speaker, is 21.56 milliseconds. So it tells me that delay locator, and it latches onto it, and away we go. Versus if I looked at the rear microphone, which is farther, now I click auto, and it's going to tell me that 64 milliseconds. So that's 23 milliseconds if it's offset. But I can look at the amplitude. I can click up here and zoom in. And so this is a pretty daggone flat speaker here. And so it's staying very flat in that space. If I click off here, I now can, let's compare the front row and the back row to see if our front to back levels are nice. So I'm going to click auto again. I'm going to click store live trace. So let's say front row on X right. Save that. And this is with just the main right speaker. Now click rear. I've already got my propagation delay. Store. Rear on X. Right. Okay. Now I can click off live trace. The blue line is always going to be whatever you have selected here, this microphone with whatever speakers you have on. I wish they would change these colors a little bit. It's red and kind of this brown. Those kind of look the same. So I always turn this one to recall trace and it's empty. And then I then select here on the blue guy, whichever one I want to look at. If I'm having to look at 4 traces, I'm out of luck. So now I have these 2 selected. I'm going to click view and view. And now I can compare those 2 measurements. So at the very front row, the levels versus the very back row. So now I can open this guy up and see here the discrepancy. So it looks like I'm almost at 95 here, not quite at 105 here. So within the low end, I'm barely within or just over 6 dB, but in the top end, they tend to trend nicely. There's not much I can do about this low end discrepancy since I don't have a line array or anything with line length. So I'm just going to let that go. But that's how I would be able to compare these measurements. It stores their propagation delay as well. It stores which microphone was used and the output channel. So I know what it was all driven by. And I can also change the offset if I wanted to raise that one up 3 dB, raise all of them, or take a specific trace and move them around so I can match them and compare a little bit differently. So a really cool tool to be able to have real measurement microphones going through what would be the actual workflow on this type of processor and change things and make it happen. All right, now that we've walked through the high level aspects of the software, let's build this again from scratch so we can get used to building and that workflow. So I'm going to go to File, New Project, Scratch, Build. I can add the venue, the designer name, any notes. Okay, let's do it. First, I like to create my layers. I'm going to go here. We start with layer 0. That's the default layer that if you just create something, it's going to stick it on there. I have 1, 2, 3, 4, 5, 6 more. 2, 3, 4, 5, 6. Always keep layer 0. That's going to be mains, front fill, sub, audience, stage, mics. Gonna go up here to tools, layer management. I'm gonna make that yellow. Yellow. And yellow. Audience, I can keep that color. Stage is this wacky fuchsia color. And then mics, I'm going to make them cyan so they pop out on the surface. Now that we've made our layers, let's create our stage. I'd like to add anything from a venue standpoint, so stage and then audience. So this is a really simple show. I know where the stage is. It's rectangular. The audience is going to be rectangular. We'll keep that simple today. Click and drag with our rectangle tool. I'm going to put it here, 0. I'm going to back it up 10 feet because I know it's going to be 20 foot deep, 24 feet wide. Going to 0 out on the y-axis, and here on the depth, 20 feet, width, 24. And I now have my stage right there. I can select it, rename it, stage. I do not want prediction. I'm going to go here to modifiers and extrude. And I'm going to do a linear extrusion and move it up 4 feet. And that's how I'm going to make my box. I've hit apply. Go back to layers, and right now I'm on the mics layer. I'm going to triple click on the stage layer. I'm going to make sure that's selected. So if I do anything further, but now I'm going to go to object settings. I'm going to move it to the stage. And I'm going to uncheck through. So now I see it as a solid object, and there is my stage. Now let's do the audience. Triple click on audience. Now that's selected. Primitives. Do a rectangle, gonna draw it. It's gonna be 60 feet deep, 70 feet wide. Put it, center it up. Now I'm going to back it out into the room and have it 10 feet upstage or downstage. And there it is. Rename it audience. I'm going to go back here and name this stage. Make sure I go here to object settings. People are not listing on the floor, so I want to lift up the prediction. So I keep the stage on the ground. Its position is Z. Its Z is 0, so it's even with the ground. I'm going to offset that 4 feet. So it pops that up a little bit. Go back here to model view. Zoom in some. That was Command plus, Command minus zooms in. I'm sure that's Control plus, Control minus on PC. And I'm holding down Shift and grabbing and moving this around. I'm also assuming that this is a seated audience. If it were standing, I'd put it at 5.5 or 6 feet, depending if I'm running sound for a basketball team or not. Now let's add the mains. Go back to layers, triple click on mains. I like to always start with what layer am I on, because I don't want stuff to get popped around and I hide a layer and then there it goes. So there goes my stage, my audience. I'm on mains now. I'm going to right click, insert loudspeaker system. I could choose the model of the UPQ D1. I'll keep it on output channel 1. We'll adjust that a little bit later. Its placement is going to be here. I'll fine tune that. -3, -19.5, and 20. Also going to rotate it down 8.5 degrees so that it's pointed at the back row. And there it is. We also have this center lines feature. And on a brand new project, even if I have this on, it's not engaged. So I have to right click and hit show center line. So that's going to show me where it's pointed. Now let's do the same thing again. Insert loudspeaker system. It already has the same speaker selected. I'm going to put on output channel 2. We'll rename those in a little bit. -3, 19.5. Z is 20 feet in the air. Y is 8.5 degrees. And now we have our pair of mains. Fantastic. Let's add our front fill. Right click, insert loudspeaker system. I can copy and paste a speaker, but that was giving me a little bit of bug over here on the left and adding like an extra thing. So I'm not going to do that right now. I'm going to add the front fill as an Ultra X20. And we'll do it 50 by 110, knowing that we're going to rotate it, not around the Y-axis. Go back here to objects. I always want to hit enter on this to confirm the value, but it actually just takes whatever you have fully. We're going to rotate it on the X-axis 90 degrees. We're going to have on 0. Then Y is going to be 0. And we'll have it 5 feet in the air like it's resting on stage. Go back to model view. And there's a cute little front fill on the edge of the stage. I'm going to put it, select it over here, rename it FF for front fill. This is mains left. Never know if that's supposed to be plural all the time or not. Anyway, so there's our front fill. Select it. Make sure it is on output channel 3. That's what I'm going to use for front fills. Insert loudspeaker system. Getting close here. 750 LFC is their single 18 sub. I think it's 18. Output channel 4. It's going to be 2 feet up stage. Centered on Y and also 20 feet in the air. Apply. And there it is. You have a single flown center sub. I made sure they are all on the appropriate output channels. Let's now rename these. So this is not renaming the speaker. This is renaming the output channels to correspond with the speakers. And now I can apply processing to whatever speaker. Rename this as well to sub. And it'll tell me that's all here. Now that we have our audience, our speakers, now it's time to add our microphones. Triple click on the mics layer. Right click, insert microphone. And I'm going to rename those mic positions, the front on X right, mid, and rear. And then I'm going to do my mains and fill time alignment. So you're going to learn a little bit of system design, and then my main sub alignment. So this is a little bit of data entry, so bear with me here. Front on X right, be 10, 19.5 to put it on X with the main, and 4 feet high, because that's how high my audience is. And boom, there it is on the front row. We'll add another one. Mid on X right. So this is mid depth in the audience. Insert, making sure this is also on my mics layer. So on X near, on X mid, then on X far, rear, on X right. It is 70 feet back, in line with that, 4 feet high. So now I have those three. Let's go to our top view, and they're kind of hidden by our center lines. I can click Object, hide at center line, and there they all right in a row. Fantastic. Now I need to find my main to front fill time alignment. So we're going to make sure our prediction for our SPL is on attenuation. I'm going to put it back to 12 dB and do 6 dB per color. So this is going to show me the 6 dB edge, and then 6 to 12, and then below that, hit OK. I'm going to select this single speaker and hit predict. If you're familiar with MAPP XT, this would just be the speaker out into space. We wouldn't see how that speaker would behave on an actual plane. So this is showing me on that 4 foot tall plane across my entire audience how this speaker is at 4K. And a little cheat code is I can use a little screen drawing tool or take a screenshot. This one's a little bit easier, and draw that edge of the audience where that main, the edge of it's 6 dB, and it's going along here. So I have this edge. I can keep that here. I'm using Screen Brush today. I can hide and show that. Go here and clear this. Now I have my front fill, and I'm going to have predict here. And now I can see where that front fill, its 6 dB edge, is going to cross with this speaker's 6 dB edge. So it's going to be going from here along that. And so right now I have my crosshairs for where to put that microphone. I'll clear that now, and that's where you want to align those speakers along their coverage patterns. There's 6 dB edge with the other speaker's 6 decibel edge. I will add that now, insert microphone. I'm on my microphone layer. I'm going to rename it main plus front fill time for time alignment. It was 10 feet, 6 feet, and 4. Hopefully this will land us right on it. If I bring this back, I cleared it already, but it would have been right in the middle of that little circle I drew to be like, hey, that's where this is going on. So I love that SPL feature of being able to have the 6 and lower than 6 decibel drop off. It really helps with alignment. Then also for mains to sub, I'll add one more. This one doesn't have a whole lot of magic on it since mains and sub are on a similar X plane. 55, 9.5, 4. And all this is 75% of the way back in the audience is a great just rule of thumb to have for your main sub alignment, and it is halfway between this sub and mains right. The alternative choice would be to do on axis with that speaker and 75% of the way back. So you can pull out Excel and really calculate the most optimal place, but I found 80% of the time it ends up being 75% of the way back, and one of those two spots. For this design, I'm choosing that one. So those are the 4 microphones I would have set up. And now I can see them all here, and we have built our design. We can verify with predictions that we've done it right. This needs a little bit of work since we now have the front fill is too hot. So I'll go to the processor and turn down the front fill. I think it was 6 dB earlier. Go back here and predict. Should fall in line. Yeah, so that's there, and we're just left with these edges that would need to fine tune with an outfill or have a front fill take over right here, but that is the design. There you have it. That is MAPP 3D through the lens of my eyes. Again, I don't work for Meyer. I'm not a complete expert in this software, but I know those who have been following me have been asking about this software. I've talked about ease, I've talked about Open Sound Meter, and it was time to bring up MAPP, this incredible piece of software. Make sure and go to meyersound.com and register and make an account with them. You can also watch a ton of their webinars. They are fantastic human beings and are really out there to make sure you're getting better results in the field, whether or not you're using Meyer Sound products or not. If we can level up everyone's thinking in this field, it'll raise the tide for all boats so we can all have better sounding shows and a more fluid language to talk about what we're doing here. If you can let me know below what was the biggest aha moment for you today. Did you really like how I was able to align the mains and fills with that little trick with the SPL calculation, the layer management of my workflow? Please let me know, and I will catch you on next time. Make sure and grab my Audio Math Survival spreadsheet at the link below, and thanks for watching.